So today's lesson is on solving systems of equations of word problems. And I'll post this PDF of this page on Schoology if you aren't here. You can print it off, and if you don't have a printer, then you're gonna have to copy it down. Okay. All right, so we know how to solve systems of equations graphically. We know how to solve systems of equations using substitution and using elimination. So today we're going to do some real world problems, and these are good problems for standardized tests and whatnot as well, where you will need to know how to solve a system to figure it out the most efficient way. All right, so let's look at number one. So this page has 10 problems on it. We're going to probably do 5 of the problems together, and then the rest will be your assignment. Okay, so this is notes / your assignment all in one. Coolio, you have a question so far? All right, so on the first one, the senior classes at high school A and high school B planned separate trips to the county fair. The senior class at high school A rented and filled 6 vans and 6 buses with 330 students. High school B rented and filled 12 vans and 7 buses with 450 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Do y'all know how to do this? All right, when you see, have y'all seen problems like this before? Okay, when you see problems like this, think system of equations, okay? We have to create 2 equations that will fit this information. So first of all, we need to figure out what our variables are, all right? Look at the questions they asked. They asked, how many students can a van carry? How many students can a bus carry? When I'm trying to solve these problems, I look at the question to help me figure out what is the unknown. There's 2 things I don't know, right? That I need to answer. So I let that help me figure out what my variables are going to be. And it doesn't matter which variable is which, but you have to define it in the problem. If you're using X and Y or B and V or whatever, you have to write that down in the problem. So how many students can a van carry? So I just stick with X and Y. Okay, so I'm going to let X equal the number of students a van can carry. Y'all cool with that? Okay, and like I said, you have to define it. So let X equal number of students a van can carry. So what do you think I'm going to let Y equal? How many students a bus can carry, right? So number of students a bus can carry. And I don't have a whole lot of room here. So let's write one equation about high school A and one equation about high school B, okay? Usually both equations are going to have an X and a Y in each equation, all right? So I'll write my equations down here. High school A. So the senior class at high school A rented and filled 6 vans and 6 buses with 330 students. So high school A, the senior class rented and filled 6 vans. So vans was X, right? So we know for high school A, we have 6 vans times the number of students a van can carry. Would y'all agree with that? Plus 6 buses. So 6 times Y, that's the number of students a bus can carry, with 330 students. So wouldn't that equal a total of 330 students? If we multiplied the number of vans times the number of students on each van, plus the number of buses times the number of students on each bus, wouldn't that give us the total number of students on the buses? Okay, so y'all cool with high school A so far? Everybody understand how I came up with that? Oops, sorry. I'm not a technical video YouTube star. All right, high school B, obviously. High School B rented and filled 12 vans and 7 buses with 450 students. So make sure you put the 12 with the right variable and the 7 with the right variable, okay? So 12 vans, so that's 12 vans with X number of students on each van. So 12X plus 7 buses. So 7 buses times the number of students on each bus, 7Y, and that would give us a total of 450 students. Y'all down with that? Creating the equations is obviously the hardest part, okay? But was that really that difficult? No. So once you've created the equations, do we know how to solve a system of equations? Which remember, a system means you have more than one equation. Do we know how to solve that? Do y'all want to solve this using substitution or elimination? I would say elimination, because remember, substitution works best if one of your equations has a term with a coefficient of 1. Do either of your equations have a term with a coefficient of 1? No. Top equation, coefficient 6, coefficient 6. Bottom equation, we got a coefficient of 12, coefficient of 7. So I would say substitution is not going to be my best shot. I would go with elimination. So to use elimination, your terms have to be lined up. Are my x's lined up? Yes. Are my y's lined up? Yep, they got to be on the same side of the equal sign. Are my equal signs lined up? Are my constants lined up? Okay, is anything going to eliminate automatically? No, it's not. I'm going to rewrite this up here. Using elimination, what do you think is going to be easier to get rid of? The x's or the y's? Why the x's? I just have to multiply one equation. If I get rid of the y's, if I eliminate the y's, I'll have to multiply both equations by some number, right? Can you do that? Yeah, totally. But, you know, usually we try to do the least work possible, am I right? So if I want to eliminate the x's, that's going to be less work. So that's what I'm going to do. So if I want to eliminate the x's, I'm going to multiply which equation by what number? Top equation by -2. Because if I multiply by +2, it's going to turn that term into 12x. And 12x and 12x make what? 24x, doubles. We need it to make 0. So if they're both positive, one has to be negative. So I'm going to multiply that top equation by -2. And remember, the biggest mistake students make is they don't multiply every single term in the equation. They only multiply 1 or 2 terms. You got to multiply every term. Otherwise, you change the meaning of the equation, and that's not okay. Okay? So -2 times 6x is -12x. -2 times +6y is -12y. -2 times 330 is -660. And you say the bottom equation, I don't have to multiply by anything, right? So I'm just going to rewrite that, line it up. Now, does anything eliminate? Yeah, -12x and +12x make 0. We say they cancel or they eliminate. That was the goal. Now combine like terms. So it's -12y plus 7y. -5y. What is -660 plus 450? -210. Then we will divide by -5. So -5y divided by -5 is +y. -210 divided by -5 is +42. So what does that tell us? 42 is what? Number of students on one bus, right? So 42 students per bus. How are we going to find how many students a van can carry? Substitute it into what? either one, either original equation. I can also substitute it into the equation that I created because it's equivalent to this equation, but my numbers are bigger, so why would you? But we could, okay? But once you know what y is equal to some number, you can substitute it into either original equation and solve for x. Will you get the same answer regardless of which equation you choose? Yes, because it's the ordered pair they have in common, right? So I will substitute it into, I'll just use the top equation. 6x plus 6y equals 330. So we know there are 6 vans with however many students are on each van, plus 6 buses, and each bus carries 42 students. And in high school A, there were a total of 330 students. So let's see, 6 times 42 is 252. Just double check, 6 times 42. So we have 6x plus 252 equals 330. And I'm running out of space, so what would I do now? Subtract 252 from both sides, so I'm not going to show my work. I'm just going to say 330 minus 250.
I'm very, very disappointed to have to share with you that some of our bathrooms in our new building 49 have been vandalized. Students, you know that is not displaying or demonstrating the R in our Jacket Pride. It's not demonstrating Jacket Pride at all. And again, we're very, very disappointed. We have barely gotten into this new building, and already some of our students have been said to cause damage. Students, we know that there are videos trending on TikTok that it's cool to do these kinds of things. However, I will say that students who are caught doing this will be prosecuted, we will be charged. There are various levels, and for the school system, it can be up to expulsion. Then there are also consequences on the law enforcement side. Students, if you are aware of any of your classmates who have conducted this type of behavior and have caused destruction of the property within our bathrooms, I would ask that you get with an administrator or one of our SROs. It will be confidential. Once again, students, I'm very disappointed. Both of these bathrooms are locked in building 49. Students, we have a large percentage who would never ever do anything like this. And I ask that you watch, and if you see and know who could have done this type of thing that you want to know. Again, he will be charged. There will be consequences at the school level as well as on the side. Thank you. I apologize once again for having to interrupt classes with this type of information. Again, we are very disappointed, and we do expect to be able to find those students who committed this defamation on property. Thank you.
I just saw that on the news this morning. That is like a thing. You will be charged and arrested when they find out who it is. So don't do that. And if y'all know who did it, report it. You can be anonymous, for sure anonymous. Okay. And do not do that. I know y'all would never do that, but I don't understand it. Anyway, back to this problem. So I finished and solved the x is equal to 13, right? Yep. Okay. So let me just check this real quick. So for high school A, I'm saying that there's 13 vans, and high school B, I'm saying there's 42 vans. Let's see about, or no, I'm sorry, I said that wrong. High school A, there's 13 students on a van, right? And 42 students on a bus. So let's see, if I have on high school A, 6 vans times 13 students, that's 78 students in vans, and I have 6 buses times 42 students on a bus, that's 252 on a bus. How many did I say were on the van? How many? 48. Add those together, Something wasn't wrong.
It was 70.
Oh, so 78 plus what? 232? 252, 330. So that works. So that makes that true. Let's see if it makes high school B true. So you'll help me remember the numbers. So there was 12 vans for high school B with 13 students on each van. So 12 times 13, that's 156 students in vans. Y'all remember that? 156 students in vans. And there were 7 buses with 42 kids each. So 294 kids on a bus, plus how many students were on vans? 156. I mean, that didn't even sound familiar. See, I can't remember. 450 students. So did we do it right? Yay. Questions on that? All right. Let's look at example 2. Oh, we should say this. We didn't really answer the question. Don't give this to me as an ordered pair. Answer the question. It's a word problem, right? So how many students can a bus carry? Or I'm sorry, a van can carry. A van can carry, we said vans were X, 13 students each. And how many students can a bus carry? And a bus can carry 42 students each. Coolio. Again, y'all know how to do the math part of it. It's just setting up the equation. It's not hard. The more practice you have, the easier it is. Right on? Right on. All right, look at number 2. Not sure how to say this name. I hope I say it right. Anjali. 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 Has anybody seen that name before? And can help me before I butcher it? Okay, well, I'm going with Anjali. Anjali and Mike are selling pies for a school fundraiser. Customers can buy apple pies and pumpkin pies. Now I'm hungry. Anjali sold 1 apple pie and 10 pumpkin pies for a total of $205. Mike sold 7 apple pies and 4 pumpkin pies for a total of $181. What is the cost of each? What is the cost each of 1 apple pie and 1 pumpkin pie? So what do we need variables for? Exactly. Not how many apple pies, not how many pumpkin pies. It's the cost for 1 apple pie and the cost for 1 pumpkin pie. Does it matter what variable I use? No, I have to define it though. I can't just put variables and not tell you what each one stands for. So I'm going to let X equal the cost of, I just go in the order they asked, of an apple pie, of 1 apple pie. And I will let Y equal the cost of 1 pumpkin pie. Now, so that part's easy, but kids will be like, well, I don't know, like, what's each equation supposed to be about? I look at when they give you totals, okay? They gave you 2 totals, right? They gave you the total of what Anjali sold, and they gave you the total cost of what Mike sold. So that helps me know, okay, one equation just needs to be about Anjali, and one equation needs to be about Mike, okay? Because one total was about Anjali's total, one total was about Mike's total. On the last equation, they gave you 2 totals, 330 students, 450 students. One total was the total number that high school A brought. The other total was the total number of students in high school B brought. So I knew one equation had to be about high school A, one equation had to be about high school B. Does that make sense? Okay, so let's figure out, let's do one equation about Anjali and one equation about Mike. Y'all down with that? So Anjali sold 1 apple pie and 10 pumpkin pies for a total of $205. What do you think my equation is? She sold 1 apple pie. Okay, so X, I don't need to say 1X, do I? Plus, she sold 10 pumpkin pies. So 10 times the cost of each pumpkin pie equal the total of how much? $205. Mike sold 7 apple pies and 4 pumpkin pies for a total of $181. So what's Mike's equation? Equals $181. Y'all down with that? That's not that bad, is it? No. I don't remember learning this in school. I'm sure I did. But I remember taking whatever test, ACT, and they have questions like this, and I would just try and figure out numbers, which takes a really long time, and I probably never got them right. And if I just remembered I had to write a system of equations, so much easier and more efficient. Okay, do y'all want to use substitution or elimination? You do? Can we use either? I can use substitution. Is that okay? Can we use elimination? But y'all would rather use substitution? Okay, let's do it. So if I'm going to use substitution, which equation am I going to, do either equation have an isolated variable? No. But one of these equations, it'll be easier to isolate a variable than the other? The top one. And what variable will be easiest to isolate? X. Why X?
Because it's a
coefficient.
Yes, coefficient.
Its coefficient is 1, right? So if I'm gonna use substitution, I gotta choose an equation and a variable to isolate if it's not already. So we said we're isolating the X. So how would I do that? Subtract 10y from both sides. So that would be X equals negative 10y plus 205. Yes? Sha? So I now know that X equals negative 10y plus 205. Eventually, X will be a number, but right now that's all we got, right? So when you're using substitution, after you isolate a variable, what do you do with that? Plug it into what? The other equation. You can't plug it into the same equation. So substitute is the word we use. So the other equation, 7x plus 4y equals 181. I now know that x is equivalent to negative 10y plus 205. So where I see x in the other equation, I'm going to substitute in negative 10y plus 205. Okay? So instead of 7 times x, it's going to be 7, open parentheses, negative 10y plus 205. Everything else I just bring down. So bring down your plus 4y, bring down your equal sign, bring down 181. So now notice this next step, I don't have x's and y's in this equation. I only have y's. So when you just have one variable, then we can solve for just that variable for a number, not an expression. Like over here, we had 2 variables. So the best I could do was solve for an expression, but now I can solve for a number. So let's distribute. So 7 times negative 10y is negative 70y. 7 times 205 is 1,435, and that's positive. Just double check that. And then bring down your plus 4y. Bring down your 181. Now, before I start moving stuff from one side to the other, can't I combine negative 70y and positive 4y before I move on? Yeah. What is negative 70y and positive? And they're on the same side, so I don't change any signs. Negative 66y plus 1,435 equals 181. Now what? Subtract what? Exactly. Subtract 1,435 from both sides. And I'm gonna have to bring this up here. So I'll have negative 66y equals 181 minus 1,435. I get negative 1,254. Of course, I always check myself before I wreck myself. And then I'll divide each side by negative 66. And negative 1,254 divided by negative 66 is positive 19. So what does that tell me? 19 means what? The cost of one pumpkin pie is $19? Dang. I mean, that's a lot of money for a pie. Must be a really good pie. Besides the point. It's not 19 pumpkin pies sold, right? Why was the cost of one pumpkin pie? So one pumpkin pie costs $19. And Jolly sold 10 of them. Hers must be good. All right, how are we going to figure out the cost of apple pie? Substitute 19 into either original equation. Does it matter which one? No, I'll just go with the top one. X plus 10y equals 205. So we know that a pumpkin pie costs $19, so that's why. So X plus 10 pumpkin pies at $19 each equals $205. So X plus $190 equals $205. Okay. 15. That's what my calculator says. So do I want to write my answer as an ordered pair? No, it's a word problem. We got to answer the word problem. There were two questions. What is the cost each of one apple pie and one pumpkin pie? How much is the apple pie? $15. So one apple pie, sorry, I don't, I limited my room here, costs $15. One pumpkin pie, now I'm ready for Thanksgiving, cost $19. Are y'all down with that?
So it doesn't matter like which one you choose. Like, I don't know.
You missed the first one.
Yeah. So how are you putting them together?
I'm going to do another one.
Like that?
Okay. It's another one about vans and buses. Let's skip 3 since we just did one about vans and buses. Let's look at 4 about Willie and Jill selling cookies. I like cookies too. So we'll skip 3. 3 will be one that you will do for your homework. Okay. We'll move on to 4, Willie and Jill. Willie and Jill are selling cookie dough for a school fundraiser. Customers can buy packages of chocolate chip cookie dough and packages of gingerbread cookie dough. Willie sold 2 packages of chocolate chip cookie dough and 3 packages of gingerbread cookie dough for a total of $38. So they just gave us a total that Willie sold. So you think we're going to have one equation about Willie? Mm-hmm. And Jill sold 6 packages of chocolate chip cookie dough and 12 packages of gingerbread cookie dough for $144. They just gave us another total of what Jill sold. So do you think we're going to have an equation about Jill? Some kids make the mistake of they do one equation all about gingerbread cookies and one equation all about cookie dough cookies. Usually you're going to have 2 variables in each equation, 2 different variables in each equation. Okay, so be careful about that. So find the cost each of one package of chocolate chip cookie dough and 1 package of gingerbread cookie dough. So remember, I told you to look at the question asked to figure out what your variable is going to be, right? Does it matter what variable you choose? No. So I usually go with X and Y. So I'm going to let X equal the cost of 1 package of chocolate chip cookie dough. And then I'll let Y equal the cost of 1 package of gingerbread cookie dough. Coolio. So remember, let's look at our totals. We know Willie sold 2 packages of chocolate chip cookie dough and 3 packages of gingerbread cookie dough. So we know how many of each he sold. When we know the total, we're going to find how much did cookie dough cost, how much did chocolate chip cost. So we're going to have one question all about Willie. And then the other total was for what Jill sold, which she sold 6 packages of chocolate chip cookie dough and 12 packages of gingerbread cookie dough for a total of $144. So make sure you put the right variable with the right numbers, okay? If you let X equal gingerbread and Y equal chocolate chip, that's cool, but your numbers need to match up with that. So Willie sold 2 packages of chocolate chip cookie, 3 packs of gingerbread for a total of 38. What's my equation?
2x plus 3y equals 38. And for Jill, you'll have 6x plus 12y equals 144.
Y'all agree? So for Willie, he sold 2 packages, so 2 times the cost of chocolate chip cookie dough, plus 3 packages times the cost of each package of gingerbread for a total of $38, right? Makes sense? Jill sold 6 packages, so 6 times the cost of each chocolate chip cookie dough, plus 12 packages of gingerbread, so 12 packages times the cost of each package for a total of $144 sold. Right on? Everybody agree? Okay. So we have a system. We got to solve. We got to figure out what was the cost of chocolate chip? What was the cost of gingerbread? What method do you want to use? I agree. It looks like whether we eliminate the X's or the Y's, it's going to be the same amount of work, right? Because do I need to multiply both equations to get rid of the X's or one? One. For the Y's, do I need to multiply both equations or just one? One. Notice everything's positive, so we're going to have to make something negative, right? So what do y'all want to do, the X's or the Y's? Okay, what would I need to multiply? Which equation? The top by -3. And I'm going to bring that down here, okay? So I have to distribute every single term in the equation. -3 times 2x is -6x. -3 times +3y, -9y. -3 times 38, -114. That negative sign, soup's important. I don't need to multiply the bottom equation, which was 6x plus 12y equals 144. Everybody cool? Do my x's eliminate as I had hoped? Yeah. So my x's eliminate. And what's -9y plus 12y? 3y equals -114 plus 144. What'd you get? That's what I got too. So then we will, and y equals 10. So what did we just find out? Which is
The cost of 1 gingerbread cookie dough.
the cost of 1 package of gingerbread cookie dough. So how are we going to figure out the cost of the chocolate chip cookie dough? Substitute it in. Can I use either one? Yeah. Will I get the same thing? Cha. So which one do you think I'm going to pick? You know it. Do I have to pick that one? No. So I know the cost of gingerbread cookie dough. So that's y. So 2x plus 3 times 10 equals 38. That's going to be 2x plus 30 equals 38. Then I shall subtract 30 from both sides. We're just solving an equation here. And I get 2x equals 8. Divide by 2 and x equals 4. Do I just write 4 comma 10? Bless you. No, if I was just solving a system and it was an order problem, yeah, I could just write it as order pair, 4 comma 10. If I were to graph these two lines, that's where they would intersect, 4 comma 10. But it's a word problem, so we need to write it out. So x is 4. X was the cost of 1 package of chocolate chip cookie dough. So 1 package of chocolate chip cookie dough cost $4, and 1 package of gingerbread cookie dough cost $10. I don't wonder why the cookie dough is so much more affordable than that gingerbread. Right, I love both. Chocolate chip costs $4. I'm going to put each. Gingerbread costs $10 each. Everybody cool with that? Do we have a question? Comment or concern? All right, let's do number 5. So normally, I try to conserve paper, and I would make y'all write out all these problems. I thought I was being nice. I made copies. So, but I don't hear anybody complain about their hand hurting. I don't know. I thought I heard somebody say, my hand hurting. Like y'all asked last year's kids. We write everything. Huh? Oh, we're not taking a brain break till we're done with notes. Let's do one more problem. Okay. And then I'll just give you 6 problems for homework. Or we do 2 more problems.
No, yeah, 2 more.
No. So can I go faster on this one, do you think? Okay. Number 6. Shreya School is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 7 senior citizen tickets and 13 child tickets for a total of $112. So do you think one equation is going to be about that? So they gave you a total.
Yeah.
The school ticket took in $126 on the second day by selling 14 senior citizens tickets and 12 child tickets. So that's another total. So we've got day 1 and day 2, right? So I have one equation about day 1, one equation about day 2. Find the price of a senior citizen ticket and the price of a child ticket. So I am deciding to let X equal price of senior citizen ticket. Can I let Y equal the price of senior citizen ticket? Sure, it's up to you. You have to define on your paper what means what. So I'll let Y equal the price of child ticket. So one of my equation is going to be about the first day ticket sales. And my other equation will be about day 2 of ticket sales. So day 1, 7 senior citizens tickets sold. So 7x plus 13 child tickets. So 13y for a total of $112. Y'all agree? Day 2, total $126. They sold 14 senior citizens. So 14x plus 12 child tickets. 14x plus 12y equals 126. Y'all down with that? What's going to be able to easier? I'm going to use elimination. What's going to be easier to eliminate, x's or y's? You know it, by multiplying the top equation by -2. So when I do that, I get negative 14x minus 26y equals, what is that, 224? I always have to second guess myself. Negative 224. Do I need to multiply the bottom equation by anything? Nope. So that's 14x plus 12y equals 126. My x's eliminate as I suspected. Negative 26y plus 12y is negative 14y. And negative 224 plus 126 is negative 98. If you got a negative number here, would you think something might be wrong? If it said it cost negative $7, would you go, oh, that's weird. Something might be wrong here. Because it can't cost negative dollars, right? All right, so it looks like the price of a senior citizen ticket is $7. To find the cost of a child's ticket, I will substitute that into either original equation. I'm choosing the top equation. I know that a senior citizen's ticket costs $7. So 7 times $7 plus 13y equals 112. That gives me 49 plus 13y equals 112. Subtract 49 from both sides.
Oh,
Whoa.
You put, yeah, you put that in for X instead of Y.
Yeah, I was getting real confused.
Oh, I'm sorry. I wrote y and I brought down x. Thank you. So 7x. I'm sorry. My bad. I hate when I do that on video. Y'all know I make mistakes. You know it. But thank you for telling me now instead of not telling me. That's what I get for trying to hurry. So I found y, not x. So 7x plus 13 times 7 was 112. So 7x plus 91 equals 112. Subtract 91 from both sides. And 112, did I do something else wrong? I get 21. So x is 3, right? Okay. Whew. So one senior citizen ticket costs $3 and one child ticket costs $7. Y'all know when you see senior discount, they're not talking about seniors in high school.
Yep.
Really, do you? Because I didn't know that in high school. And I remember going to, we had a place called Shoney's. You ever heard of Shoney's? Shoney's. And I told my mom I couldn't wait to be a senior because I couldn't wait to get a discount at Shoney's. And I meant senior in high school, but it's senior citizen discount. So y'all were smarter than I was. All right, are you sure you don't need me to do any more?
You want to?
They're all just like this. Okay, they're all just like this. Because if we stop for a brain break, we're not coming back. Okay, how about I keep on going for the video, and y'all can take a brain break if you don't need to watch me. Okay, who needs to go to the bathroom? Can we go one at a time? While I continue. No one needs to go to the bathroom? Okay, so 10 minutes, if you have your phone out in this 10 minutes, 9:54 till 10:04, I'm not gonna say anything and then we're gonna get busy, but I'm gonna do number 7 for the video for the children at home who need one more example, okay? Pay attention if you want. Either way, you're responsible for this when I check your assignment next class. All right, so number 7, Gabriella and Apasara Each improved their yards by planting rose bushes and ivy. They bought their supplies from the same store. Gabriella spent $121 on 7 rose bushes and 7 pots of ivy. We know one equation is going to be about Gabriella. It gave us a total. Abhasra spent $172 on 4 rose bushes and 12 pots of ivy. So they gave us another total. We know one equation is going to be about Abhasra. What is the cost of 1 rose bush and the cost of 1 ivy plant? So my variables come from the questions. So I'm going to let X equal cost of 1 rose bush. And I'm going to let Y equal the cost of 1 pot of ivy. Like I said, one equation is going to come from what Gabriella spent. And one equation is going to come from what Abhasra spent. So Gabriella, she spent 121 total. So I know it's going to equal 121. She bought 7 rose bushes. So X is the cost of 1 rose bush. So 7X plus 6 pots of ivy, 6 pots times the cost of each pot for a total of $121. Abhasra spent $172 total. So I know it's going to equal 172. He bought 4 rose bushes. So 4X plus 12 pots of ivy, 12Y for a total of $172. I am going to choose to eliminate my Y's because that way I only have to multiply one equation, which would be the top equation by -2. So that gives me negative 14X minus 12Y equals negative 242. Bottom equation, I don't have to multiply by anything. Sometimes I have to multiply both equations. This time, I do not. So negative 12y, positive 12y eliminate. Negative 14x and a positive 4x is a negative 10x equals negative 242 plus 172 is negative 70. Divide by negative 10. X equals 7. So I know 1 rose bush costs $7. To find the cost of 1 pot of ivy, I will substitute that back into either original equation. I'll go with the top one. I found what X is equal to, so I will substitute 7 in for X. So that's 49 plus 6y equals 121. Subtract 49 from both sides. I get 72. 6y equals 72. Divide both sides by 6. And y equals 12. So 1 rose bush costs $7. 1 pot of ivy costs $12. Anyone have questions that's still listening to me? It's not on brain break. All right, so all of you at home, the ones I did not do in the notes, well, I expected you to hit those notes. You have to do the rest on your own. So that's problem 3, 6, 8, 9, and 10 is your assignment due next class. Have a good day.
Hey,
Hey, it's me.